All right, welcome. So, this part of the lesson this will be the last lesson for lesson 37 involving the complex numbers. Okay, and here we're going to learn how to graph complex numbers on the complex plane. Okay, and if you feel fuzzy with what these definitions are, if you don't have definition of complex numbers, it's right here. This is definition of complex numbers. A complex number is in the form a plus bi, where a and b are real numbers and I is imaginary. So if you have some a plus bi, these are the real parts of it and this is the imaginary part. And the definition for a complex plane is what I'll go over very soon. Okay, and now the essential question for today is, how does multiplying I affect the graphical rotation in the complex plane? And this will be a really nice question, okay, once we get to it. All right, so what I'd like you to do is have the nice Cornell note set up. Your do now for today will just be write the definition of complex numbers from over here if you don't have it, and also have the definition of complex plane. Okay, so basically the definition of this is, here if we have, we're used to this, right? If I were to say, oh look, this is the coordinate plane, right? This is the coordinate plane. It's just this and this, right? All right, so let me fix the camera angle a little bit. So this is a coordinate plane, right? And what would be in the coordinate plane? This is just 1, this is 2, this is 3, this is 4, and it keeps going, and this is -1, this is -2, this is -3, and here we get +1, +2, +3, and keep going, and this is -1, and you get the idea, right? This is the coordinate plane. This is what you're used to. But here, when we're graphing this number I, we are not in this universe, all right? So imagine we're not here anymore. We don't have the y-axis where it's 1, 2, 3. Instead, we're gonna have I, 2i, 3i, and this will be -i, -2i, -3i, okay? So here, our x-axis will be the real numbers, and this is the real number line, and our y-axis will be the imaginary numbers, okay? So question is, how can we graph complex numbers on the complex plane? Well, let's take a look at the sheet, and let's go to, so if this is our lesson 37 sheet, right? Let's go to question problem set number 1, okay? So take a second to look for it, and let's get to this point. And now here it says, locate the point on the complex plane corresponding to the complex number. So here, let's look at A. It says, where is 5 plus 2i? Well, let's do it one at a time. Where's 5? 5 is here, and 2i is here. So 5 plus 2i has to be here. This is 5 plus 2i. And now here it's saying label each one A to H. So if this is A is 5 plus 2i, let's put an A over here. Okay? What about B? Where would 3 minus 2i be? So this would be 3, and minus 2i is here. This is minus 2i, so this is it right here. And that's B. What about C? It's -2 minus 4i. So this would be -2 minus 4i. So it would be right here. Okay? And for some reason, I don't know why, I guess maybe the printing is a little off, but this should be, you can't see it, but it should be 5i, 4i, 3i, 2i. There should be i's over here. You can't see it that well. Okay? So this one was C. So it's pretty self-explanatory. Why don't you just try and do the rest of them? Here, minus I will be where? Well, this is really equal to 0 minus I, so it's just 0 minus I. So this is D over here. E is 1/2 plus I, so 1/2 is here, and I, it should be like right there. This would be E. where would f be? Square root of 2 minus 3i. Square root of 2 is like here, minus 3i, so it's like somewhere over here for f. Where is g? G 0, that's just 0, that's g. And h, this nasty looking thing, will be negative 3 over 2. So it'll be somewhere here, plus 3 over 2i. Honestly, I don't even know. Maybe where would it be? Square root of 3, maybe like here? Like right there, that would be h. Okay, so that's how you kind of graph things. Okay, so we completed the first question, how we graph them. Second question, how are the coordinate plane and the complex plane similar and different? Well, here, we don't really think about it, but when we're in the coordinate plane, our x-axis and y-axis, they're real. This is the real number line, and this is the real number line. Okay, so here, how are they similar? They have the real number line for the x-axis, but for the y-axis, how are they different? The y-axis has imaginary numbers for the complex plane, and for the coordinate plane, it doesn't have. It just has the real number. Remember, coordinate plane would be real number like this, and complex plane would be real number and imaginary line. Okay, so these two are completely different. Okay, so we're living in here right now. All right, so let's go to this question over here. Let me get this. So this will be the next important part of our lesson is, let's take a look at this. If I have these questions for you, what does I equal? Okay, so I is equal to what? All right, so I is equal to square root of minus 1. Okay, what does I squared equal? Well, I squared is equal to square root of minus 1 times square root of minus 1. So this is just equal to minus 1, right? So we have that. But what's I cubed? Okay, well, let's see. What is I cubed? If we know I cubed, what is that equal to? So I cubed, is it okay to say that I cubed is equal to I squared times I? Is this true? So, because it's the powers of the exponents, right? But I squared is equal to what? It's equal to minus 1. So I squared times I is equal to minus 1 times I. So that's equal to minus I. All right, so I cubed and minus I are equal to each other, right? If I just had I is equal to I, but minus I is equal to I cubed, okay? And if you're thinking, why is this important? It will get very important soon, because once we know these four, we're going to know the rest, all right? So here, what is I to the fourth? This is what? I to the fourth, isn't I to the fourth equal to I squared times I squared? But I squared is what? That's negative 1 times negative 1, and that's equal to positive 1. Okay? But now let's look at this. What's I to the fifth? What if we did I times I times I times I times I 5 times? But look, I to the fifth, isn't that equal to I to the fourth times I? But that's just equal to what? I to the fourth is 1. So this is just 1 times I. So this is just equal to I. I to the fifth is equal to I. These two, this is similar. What I'd like you to do is keep going. Try and find I to the 6, I to the 7, I to the 8, I to the 9, I to the 10, I to the 11, I to the 12, and then hopefully we'll see some sort of pattern. Okay? So pause the video and try and do that. And if you feel very confused on what's going on, and it's okay to be confused, just raise your hand or give a shout out and I will assist you with this. But if you were to solve these, I to the 6 is minus 1. This should be minus I. This should be 1. This should be I. This is minus 1, minus I, 1. They are literally the same. It just repeats. It's just, this is it. And if you're thinking, how does this work? Well, let's take a look at it. Let's say if we're at I, right? Imagine we're here. So let's do 1i. If we multiply by I, don't you remember what happened? It would be what? A 90-degree rotation. So I times I is minus 1. So here, I is equal to I squared is equal to minus 1. What about I cubed? What if we did this I times another I? Well, that gets us to what? It gets us to minus I, right? And that's what we have here. I cubed is minus I. What if we did times I again? This will go to 1. And that's what's happening. This is I to the 4th. That's equal to 1. So every time you multiply by I, you're just doing a rotation. So this is what? How many i's did we do? We started at 1i. So this is I squared, I cubed, I to the 4th. This is I to the 5th. And I to the 5th is equal to I. And we have that here. I to the 6th is times another I. And it just keeps going. This is I to the 6th. And that's equal to minus 1. Okay? Whew. All right. What I'd like you to do is try and do this question over here, where it says, question 5. How does multiplying by I get us through this? And once we know this, these will be very nice questions. Imagine if I said, what is I to the 5th, I to the 6th, I to the 7th, I to the 8th? We actually just did these right here. But what if I said, what's I to the 202? What would that be? So why don't you think about it and we'll discuss it as a class. Okay, I'll see you.